So we finished most of it. We said a chemical change is a change that actually produces a new substance. What you end up with after a chemical change is something different than what you started. It's not the same material anymore. Examples of chemical changes.
Undo onion rust. No.
What's that?
No, undo the rust.
You can remove the rust often, but it's...
But it won't be the same.
And yeah. So, clues that a chemical change has taken place. Sometimes heat will be released when you combine two chemicals. That's a sign of an exothermic reaction. Okay? And these are just some pretty poor videos, but they show adding substance together and you have a chemical reaction taking place. Precipitation, no. Getting a precipitate, which is when you mix two liquids in a solid forms, is an example of a chemical reaction. Bubbling, or the release of reactions. Well, here's an example of precipitation.
Oh, those the same colors, like, were they? Yeah. How was that precipitation?
Solid.
There's a transparent thing going to a transparent
Yeah.
thing and turn,
Yep.
right?
So these are examples of chemical reactions. Yes.
Why on the left side of this video does it look like there's just a gigantic line of computer code going on?
Oh, that's the matrix. Yes, Lindsay? Okay.
Why are you? It doesn't give you a headache?
No. All right, so in a chemical change, we know by the law of conservation of matter that there's no gain or loss of mass. When you have a chemical reaction, what you end up with is the same mass as what you started with, because we know we cannot create or destroy matter. We're basically just transforming it from one form to another. Volume may change. So while the mass doesn't change, volume is. Volume can vary. Kayla? Yes, Lindsay?
When was our task going to be on next?
I don't know.
Oh,
Probably towards the end of
Next week.
the week we come back.
Will we, no, stop.
Go ahead.
Wait.
Aish.
Oh yeah, I remember now. Are we gonna have like a quiz in the middle of the unit, or we have
No,
just a big quiz?
because this unit we're going to be done with next the week after probably. All right, so let's talk a little bit about the three. Now, does anyone see a problem with the title of my slide?
Yes, I do.
What, Victoria?
There's no plasma.
Okay, plasma's not listed, but something else.
It says 3/6 of matter, those matter are 4/6 of matter.
Yeah, there really are four, but I was sort of thinking something else.
You can't exactly put a picture in for gas.
Well, no, I kind of want to try at least. What I was thinking is that common is the problem, because really, like I told you that plasma is technically the most common state of matter in the universe. Maybe not on Earth, but it is the most common yes, Jax?
Didn't you say Mr. Arcade did this, so it's not your fault?
Oh, true, that's a good point, Jax, yeah. Mr.
No, but
Arcade
it
made
says on the front, Mr. Arcadia, Mr. Duras.
Yeah, but that was just because I'm using them in my class. Mr. Arcade is the author of all
Wait,
the
so if we
states.
went over and asked Mr. Arcadia if he made these notes, he would say yes?
He would.
Then
You
go
asked him
ask
after
him,
class,
go
no,
ask
at the end
him.
of class.
And on the front of his notes it just says Mr. Akiri, so that's why.
Oh, it does?
Yeah.
Jeez, he took me right out of there. All right, so let's, this is just a real brief summary. It's actually not that brief, it's 3 slides long, but if we think about making, envisioning what the molecules look like in a solid, they are neatly arranged, fairly tightly packed.
We have to draw this?
Let's draw a few of them, yeah. Whereas in a liquid, they are in a more irregular pattern. They're spread out a little bit. And in a gas, they're even farther. The words that we use. Solids, we say, are frozen. A liquid is a fluid. A gas is a vapor. Happy?
Are we going to need to know these for the
Yes.
You know those like Vicks sticks that are like vapor? Does that actually like
They're just called vapor. Yeah, but I mean there are certain, like the menthol in there evaporates, I guess, and that's what makes it smell like that, you know, whatever menthol smell. Shape. What can you tell me about the shape of solids? We're looking for one of two words here. Yusuf?
Definite.
Has a definite shape. How about liquids? Ryan?
Definite. Or it takes the shape of its container.
Yes, no definite shape. It takes the shape of whatever container it's put in. And gases, Victoria?
Not definite.
Yes, no definite shape either. How much movement is taking place in the molecules of a solid compared to liquid compared to a gas? Matthew?
There's not that much in solids.
Yep, and how about liquid?
There's more than solid and less than gas.
Yep. And then gas is the most. So in solids, the molecules are basically just vibrating, staying in position. They have the least amount of movement. In a liquid, molecules are moving freely. They trade places with another, but they basically stay together in the same area. In gases, the molecules move the most, they're moving the fastest, and they're not really bound to each other in any way. Okay?
So basically, are you saying that people are frozen?
Yes, well, we have fluid in our bodies as well, so we're a mixture of all the shapes of matter.
We are Homo sapiens.
We are. Michaela?
So what you're saying, like with a solid, with a slight like vibration, like are you saying the shape could change? Or-
No, I mean, because in a solid, for example, a block of aluminum, the molecules basically stay in that position. That's why it maintains its shape. But they are vibrating in there. There is movement on those molecules. Now, it's at such a small level, we don't see it, we don't feel it, but the molecules are moving.
Or if you cut it, like, won't still have the movement.
The molecules will still be moving the same
Yeah, but
amount.
you said it has a definite shape if you cut it.
Then you're changing the shape. But then those two pieces maintain their shape. So you can change the shape of a solid, but it stays in its shape, so it does have a definite shape.
The thing like butter, what would that be classified as?
A butter with a fairly high melting point. Same with chocolate. You know, chocolate is a solid at room temperature, but up around temperatures of 95 or so, it starts to melt. So it melts at a fairly low temperature. Yusuf?
Wait, oh yeah, you know those massage things? Massage chairs.
Oh, like a chair, yeah.
Would you not like those that be vibrating really, really fast? Since the whole thing is vibrating, if it was vibrating really, really
No, that's mechanical motion of pieces of the whatever plastic material it's made out of. So sort of different, but they are moving in that. Yeah.
So could chocolate turn into a gas if it was warm enough?
Now, chocolate is sort of a complex compound, so may. But generally, when we talk about the melting and freezing point of things, we're generally talking about simple compounds or elements. How about freedom? How much freedom do they have, Nicholas?
Very little.
Which solids have what?
Very little.
Liquids?
A lot, well, more than that, and then you guys have a lot.
Yes. So in solids, the molecules basically stay in place. In liquids, they are free to move around, and in gases, they're free to go wherever.
How fast are the molecules in plasma move? Faster than
Yes,
gas?
faster than the others. Compressibility. So how easy is it to squeeze a given number of molecules into a smaller space for solids? Victoria?
It would be hard to squeeze.
Yes, almost impossible. Very difficult for liquids as well. This is why hydraulic systems are able to work efficiently. Hydraulics who use water to apply mechanical force to some object. And if the water, for example, or the fluid compressed very much, it wouldn't work very well. David?
Well, apparently, if you squeeze some things small enough, it creates a black hole. Like if you were to squeeze the Earth to the size of a peanut, it would create a black hole.
Okay, that's because of an immense amount of mass in a very tiny space.
Yeah.
Well, how are you gonna get the Earth to be a peanut?
Luckily, we have nothing that can do that.
But
so-
he's saying if.
What if it's crushed?
This is a hypothetical. Victoria.
Well, how would squeezing like gas be easy? So if I just like went like this, am I?
No, but you could compress a gas. Like when you go refill a propane canister to cook out on your grill, they're basically forcing tons of, not tons, literally tons, but they're forcing large amounts of propane gas into that container, and it's compressing it into that container.
So if we had like a box that you could just like make it smaller, how would the air get out of it?
It wouldn't. If the box is airtight and you compress it, the molecules will get closer and closer.
Is that like to change like
Good. Victoria?
What are we like? What are we? Are we like solid or like?
We're a mixture of all states of matter.
So we have gas.
Yeah.
Okay, just like
All right, density. How does the density of each state of matter compare? How about some new participation here? Andrew.
The density of solids is very high.
Yes? Solids have the highest density, the molecules are fairly compact. Liquids are in between, and gases are usually the least dense.
Why does it say H2O exception?
Why does it say that? You guys tell me, we talked about this the other day. You know, Yusuf?
Yeah, because
Yeah, because solid water is less dense than liquid water.
wait,
Wait, I don't get it.
solid water.
Solid water
okay.
is less dense than liquid water.
Wait, I don't.
Nearly all other materials, the solid form is more dense than.
What do you mean the solid form?
What is a solid form of water, Victoria?
Ice.
Oh.
Ice. Ice floats in liquid water. Okay?
What is the definition of density? I don't understand.
How compact the molecules are, so how close together the molecules are. So something that's very dense in a small area has many molecules and therefore has a greater mass.
Like a rock?
A rock would have fairly high density.
Like if you're talking about water and ice, and like, would the rock have a lot of density or compared to the ice?
A rock would have greater density than the water, or the ice, both. Yeah. But within a single material, within water, the solid form, ice, is less dense than the liquid, and that's unusual. Most of the times the solid
But isn't
is.
the ice heavier?
Nope. And density and heaviness are two different things. Lindsay? Oh, I thought you were in there. All right, volume. Jax, solids?
Definite.
Definite? Liquids?
Definite. And indefinite.
So the volume of solid liquids is definite and measurable, and gases is not definite. Gases expand to fill whatever container they are.
So, what did we do yesterday? Because I wasn't here and I don't understand this.
Volume. So if I have, let's say, a solid, a cube of aluminum. It has definite shape, we just talked about that. And it also has a definite volume. I can measure it, and I can measure length and width and height of that cube and calculate how much space it takes up. That's what volume is, how much space it takes up. For a liquid, I can do the same thing. Somebody gives me some liquid aluminum, okay, I could measure its volume, could pour it into a container, and I could find its volume, it'd be a definite volume. But a gas, if I had gaseous aluminum,
Is that a thing?
I don't know. Yes, all elements can go through all three states of matter. The question is at what temperature, and it must have a very high boiling point. So I guess it is technically possible. I don't know if actually it is possible. But then that would expand. Gases expand whatever room you get. Just like if you think about it, if you have a balloon, you seal it off, the volume of the helium in that balloon is whatever the size of the balloon. If you let go, what happens?
It comes out.
The helium expands and it takes up more space, comes out, and it expands to fill up the room you're in.
So what would happen if you put like liquid silver in water? Like if you just poured like a whole cup
It would just sink to the bottom because it's
would it
much
be,
more
like, a weird
dense.
shape?
Well, wouldn't it solidify then? The silver would be hot.
What's that?
So don't you have to make sure?
Oh yeah, the silver would have to be very hot.
Like
And
you pour it in water
Then
and it would
wouldn't
go
it
like
no, the water would all just boil away instantly. But I mean, I think if you could, because it's more dense, it would be on the bottom. If they could be.
Like if you had a lot of water, wouldn't it solidify then?
What?
The silver?
Yeah, yeah. If-
Okay, so aluminum is a solid at room temperature, right?
Yes.
So if you were to melt it and leave it out at room temperature for a while, it would solidify?
Yeah, as it cools down.
Oh wow.
All right. The bonds between molecules. So
Yes, he does.
solids have strong bonds. That's strong bonds between molecules. That's why they have a definite shape. Liquids have fairly loose bonds, and gases have basically no bonds between molecules. They're free to go wherever. How about the amount of energy they contain? Which is the greatest amount of energy? Nicholas? No? Ayla?
Gas.
Gases do.
Wow.
Because the molecules are moving more quickly in gas. How about the amount of attraction between the molecules? This sort of goes along with our first row. Ryan?
The solids attract together the most.
Yes. And then gas is the least. About the effects of heat. What happens eventually as you heat up a solid? Michaela?
It melts.
It turns to a liquid, which we call melting. What happens when you add heat to a liquid?
it
Yes.
evaporates.
What happens when you heat up a gas? Matthew?
It could eventually turn into plasma.
It may eventually, but generally it just gets hotter and hotter.
Would it go up?
The temperature?
Like the air would go up.
The air?
Like if you like warmed up a spot of air, would it go up?
Yes, that's how hot air balloons work.
Oh.
You heat up the air in a hot air balloon,
The air balloon
making it less dense,
Oh.
allowing it to
When the
float in normal temperature air. Victoria?
But the air in the balloon is actually hot. Like
Yeah.
Oh my
You
god.
ever see a hot air balloon like a big flame they turn on, heats up the air, and more dense, cooler air.
Is a constant resupply of air being circulated through the balloon and out?
Yeah, there's not. It's not sealed at the top,
Well, it's
Yeah.
no, at the bottom.
bottoms and the top. I think the top there's a vent at the top as well.
Oh.
And then as that air inside the balloon, as it cools down and reaches back to the ambient temperature, then it's going to start to slow down and turn the flame back on. They can bring them up again. Michaela?
Okay, I have two questions.
You guys have a lot of questions today. Go ahead.
Okay, so the first one is if you heat up like gas,
Yes.
will it like eventually turn into nothing?
No, it'll just continue to get hotter and expand.
What happens if you heat up plasma?
Or-
And what is plasma?
Plasma is another additional state of matter that is a ionized gas where the electrons